Okay, let's take a look at number one. Number one's asking us, consider f of x equals this. Which of fun could be a root for f of x? Select all that apply and explain. Okay, so what you want to do for these kind of problems, if x equals -7 is a solution, right? Or roots, right? Then this means x plus 7 is a factor. Hope that makes sense. This means x minus 1/4 is a factor. Or 4x minus 1, it's the same thing, because that also gets you 1/4. You multiply both sides by 4, subtract 1, you get that. X minus 2 is a factor. X plus 4 is a factor. Now take a look at your last term. And this was on the homework. One of the homeworks, can't remember which one. If you have a plus 7, the x plus 7 could be a factor. Sure. Totally can. Because you know, 7 times 1 is 7. Forget about x minus 2. How are you going to have x minus 2 and a bunch of other junk? What are you going to multiply -2 to get to 7? It's going to have to be a fraction, right? Now, let's say you had like x plus 7 halves, or sorry, x minus 7 halves. I mean, you could write as 7x minus 2, I suppose. But the problem is that you're going to have a bunch of fractions, which is kind of weird because you don't have any fractions in the coefficients. Plus you need a 4x5 also. It's just really weird. I mean, I suppose you could have, again, you have x minus 7 halves. But it just gets weird. Then you have 2x minus 7. Yeah, it just, the bottom line is 2 is not a factor of 7, so forget about it. Like with the x plus 4, that's also out too. Now b is interesting. 4x minus 1 could work because 4x is a factor of this. And then you could also do like an x minus 7, and then maybe it's just a bunch of other junk to kind of get it to all work out. But those could potentially work, both A and B. So that's what you have to look for, is look for factors. Ask yourself, what factor would this be? And then look at the constants and the leading coefficient. And could you get those factors? That's what you have to tell yourself. Now, 2 is a very good problem. And by the way, that's a mistake. That should be x plus 2, by the way. So please make that adjustment if you have that. For those who were there during D period today, I did give hard copies for the juniors. Obviously, you're doing AP English language. You can access this in Schoology, so you can print it. That's called extra review problems, but just change that +1 to a +2. Now take a look at the graph. Where is it crossing the x-axis? It's crossing 3 places, at -2, somewhere between -1 and -2, and somewhere between 0 and 1. Definitely go -2, because that's an obvious one we could see. That means that x plus 2 is a factor. So you can do the division. Now, if your name is Nathan Fox, you do synthetic division. That's fine. I'm going to do the box division. However you want to do a division, I don't care. Because some people learn division from tutors with other techniques. But I'm going to do it this way. So remember, -x cubed. What do you multiply x get -x cubed? That would be -x squared. -2x squared. And then what do you add -2x squared to get -3x squared? -x squared. That'll be -x. Then what do you multiply to then you multiply that to get -2x. This must be positive x. That'll be +1, and that'll be 2. Okay. And something in the chat just happened. Yeah, I'm showing how to divide polynomials. Exactly what I'm doing right now. Well, let's say EN. Confirm you're speaking language is English. What? Of course, I speak English. I switched to a different language. What? Hold on. never seen this before. Sorry, this kind of tripped me out a little bit. Yeah, okay. It's the only language I speak fluently. Anyway, that was weird. Um, I'll do more division practice, but the way actually, let me just do it one more time. Like again, we're crossing at -2, so x plus 2 is a factor. Hopefully, you guys realize that. So you're going to divide this by x plus 2 because division is like factoring. You're factoring out x plus 2. How the process works: if it's x, whatever the degree is, that's the number of columns you'll make. And we're dividing by x plus 2, so you do 2 rows. And you put the leading term in the upper left corner. Then you have to ask yourself, what are you going to multiply to x to get the negative x cubed? It's kind of like when you're foiling, but you're doing the opposite. So, so you're dividing negative x cubed by x. That's going to be negative x squared. Then you multiply negative x squared 2. We know how to fill that out. That's negative 2x squared. This is part where people get a little tripped up. Then what do you put in this box? Well, take a look at the polynomial we're dividing into. Negative 3x squared is the x squared term. Well, if I have negative 3x squared, and there's a negative 2x squared, I need to add something to it or subtract something to it to make it negative 3x squared. That'd be negative x squared. Negative 2x squared, negative x squared will get you negative 3x squared. Then, what do you multiply x to get a negative x squared? Negative x. And then you just rinse and repeat. Negative x and 2 is negative 2x. You have negative x, we're going to add to negative 2x, get to negative x, positive x. What do you multiply x, get to 1, to x, you get 1. And 1 times 2 is 2. And you definitely want that to be the same as, that should be in 2, by the way. That's what I meant to say. Otherwise, it won't be a factor. Then you have a remainder. And if you have a remainder, you make an extra column. Like say, what if that were a 3? I have a 2 there, then it has to be a negative 1. And that's your remainder. But negative 1 over x plus 2 with all that other junk. But we don't see that. We see a 2, which as we should, because we want a we want to come out clean. So now, if you think about it, x plus 2 times negative x squared minus x minus 1, sorry, plus 1, equals all this junk over here. If I were to multiply that out, as you see, x plus 2, negative x squared minus x plus 1 gets you all that junk, right? Because you combine like terms, great. Negative 3x squared, negative x cubed 2. So essentially what you've done, without realizing it, you've actually factored out x plus 2 using this fancy technique. Now, how do I solve that? Quad form. So, and then that'll be provided for you. So you do negative b, which is positive 1, plus or minus b squared minus 4ac. 1 minus 4 times negative 1 times 1, all over 2a. So it's 1 plus or minus root 5 over negative 2. And the solution key is included with this also. So yeah, an exact root, so I don't want decimals. So there you go. Hope that makes sense. Here, they say that this could be expressed like this. Find what a and b are, and then rewrite as a product of linear factors. This is a little tricky. So what you're essentially doing is you're doing division again. Because you're going to divide by x squared plus 1. Make 4 columns. That's x4. That's x squared. That's x squared. And of course, that's a positive 1. Oh, I kind of goofed. You have x squared plus 1. This is definitely more challenging because I'm not going to do something like this on a test. But I just want to do it anyway, just for the sake of showing how the division works. So x squared, 0x, and 1. This has to be x squared. And then this will be 0x cubed. It'll be x squared. I said negative 5x cubed, so I'm going to put negative 5x cubed here. That's going to be negative 5x. That'll be negative 0x squared, negative 5x. Now I have 5x squared, x squared negative 0x squared, so that's 4x squared. That's 4. That's 0x and 4, and that's exactly what I want. So I don't know why I did actually 4 columns, but so that becomes x squared minus 5x plus 4. So my a is negative 5, and my b is 4. And actually I could factor that. X minus 1, x minus 4. And then x squared plus 1, hopefully you recognize that's x minus I, x plus I. Because if you solve it, x squared will equal negative 1 square root to get plus minus I. So when you ask to rewrite as a product of linear factors, that means you just want x's, like x minus this or x plus this. That's definitely a more advanced problem, I'd say. I'm not going to ask something like this on a test, but I think the principles of the division, realizing that you have something factored out, you got to do division. Hopefully you can realize that, how division works, how to write linear factors. But something that's kind of put together all like this, that won't be on the test. Just so you know. Questions? Right. Let's look at 4. How many root does this have? Well, obviously there are 2. Now, if you count it, 1, 2, there's 3 turning points. 3 degrees 4. So that means that the other 2 are imaginary. So, and the explanation is right there. 3 turning points creates 4. So, questions on that one? Okay, simplify 5. That should have been 64x cubed, by the way. That's a mistake there. So there's a formula I'll give you guys. It's called the difference of cubes, which looks like this. And I have this on Delta Math as well. Ah, there it is. John Barlow just showed up. I know it didn't feel right. I thought of here. Here we go. So that formula will be provided. So if you think about it, 64x cubed is in a cube's position. That means a has to be 4x. If I cube 4x, I do get 64x cubed. 27 is in b cube's position, that'll be 3. So that's what happens there. And that's how you factor it. So I'll ask you a question like that on the test. These are repeats from last test because some people struggle with these questions. You can group the first 2 and last 2 terms. And if you do that, you take out 2x squared from the first group. You have x minus 4. Take out 5 from the second group, also x minus 4. And that's it. And for C, you factor out 6. And then you can break that down further. Oh, sorry, x4. My apologies. That's x squared minus 4, x squared plus 4. And then the x squared minus 4 can factor out like this. Now, if we do ask for linear factors, I didn't ask for that. You can leave it like this. But if I do ask for linear factors, then x squared plus 4 has to be x minus 2i, x plus 2i, just so you know. And that's kind of tough to do linear factors for 2x squared plus 5. I wouldn't ask you to do that. That's a little strange. But you could solve for x, get plus or minus I root 5 over 2, but I wouldn't ask that. Yeah, great question, Brandon. Great question. I took words out of my mouth. I wouldn't ask you to do something like that. That's a little much. I mean, if you were to do it, you solve it. That's what you do. Yeah, that would be 2x squared plus 5 equals 0. 2x squared equals negative 5. X squared equals negative 5 halves. And then you do plus or minus. You have that. But I'm not going to ask that. And you would do x minus I5 root 5 over 2. And then x plus I root 5 root 2. But again, that's just really weird. I don't really like that. So don't worry about it. But make sure you do factor by grouping. Make sure you can do difference of squares. And make sure you also know the sum difference of cubes, which I'll give you the formula for. And I'll show you where in Desmos after I finish, you can find all this stuff. What Desmos? Sorry, I meant to say delta math. Okay. Here. That's just quad form, number 6. That's pretty straightforward. Just we are going to ask discriminant, so make sure you know how to find that. But that's part of quad form. If I do quad form, I get negative 8 plus or minus the square root of b squared, 64, minus 4ac all over 2a. And that's oh boy, what's that gonna be? 2496. This root negative 32. So it's 4i root 2. So everything by 2. So you would get that as your answer. By the way, negative 32 is your discriminant. And that's clearly giving us 2 imaginary roots. So just make sure you're aware of that also. But yeah, that's just quad form at its finest. And simplifying afterwards because you have a 8, 4, and 6 all multiples of 2. Questions at all? No? Okay. Let's keep moving. So ask a question like this. This is what you have to do. If you FOIL the top, you get 4 minus 3i minus 8i plus 6i squared. 1 minus 4i squared. Remember, 6i squared is negative 6. So I'll make that negative 6. So it becomes negative 2 minus 11i And down below, negative 4i squared is negative of negative 4, which is 5. Do 1 minus negative 4. So it's negative 2/5. It makes you separate out like that. Get a plus b I form. Okay, questions so far? You guys are quiet. Okay. Let's keep moving. Questions? Oh, question in the chat. Yes. Yeah, it's good problems. I'll pull up in the Delta map. It's just basically you're gonna see something like this: 3x squared minus 8x plus 8, and you just do b squared minus 4ac, the part underneath the square root, the quad form. If it's positive, you get 2 real answers. Negative, you get 2 imaginary answers. If it's 0, you have 1 real answer. And I'll show you where in Delta map you can get that practice. Yeah, this is newer stuff. You're asked to find the x-intercepts, y-intercept, vertical class, horizontal asymptotes. And for each equation below, state, for each equation below, state does not exist if that's the case. Okay. So we talked about this. You focus on the leading terms, means the highest exponents. So for a, it's going to be x squared over x squared, just 1. For b, x over x, which is 1. And for y, x squared over 4x, which is, of course, x over 4. That's how you figure out the horizontal asymptotes. You're looking at the highest powers because you're looking at what happens to the ends of the graph, how the ends behave. I know, Nathan and Charlotte had we had a really fun way of using politics. So far left and far right. You look at the far left of the graph, far right of the graph, the extremes, right? You're very liberal or very conservative. And where are you going to even out? I'm not sure if that makes any sense, but anyway, and you kind of look at what's most impactful, like who's the loudest politician. Okay, I'm getting off track here. Anyway, the point I'm trying to make is you look at the highest exponent from both top and bottom and compare and reduce them. So when this happens, you have x squared over x squared. That means the horizontal asymptote is y equals 1. So the graph is going to level off at y equals 1 on the far left and far right. Here will be y equals 1. Here, there is no horizontal asymptote because as x gets larger, that gets larger. So it's just going to keep going up or down forever, whatever side you're on. Vertical asymptotes is when the denominator is 0. I'll switch colors for that. So you just factor this and set it equals 0 and solve for x. And we kind of know what that is from, I think one of the other factors kind of close that one. You get x equals -1, x equals -4. Those are going to be the vertical dashed lines that go up and down. That's x equals 5. And of course, that's x equals 0. That's all. For y-intercept, that's when x is 0. So you plug in 0 for x. That's pretty easy. For part A, it's 0, -1. You get -4 over 4. For B, it's pretty easy. You plug in 0 for x, you get 0, -2/5. For C, that's pretty easy. You plug in 0. It's actually undefined. So it's no y-intercept. Lastly, for x-intercepts, that's when y is 0. So really just gotta look at when the top is 0. So for A, that'll be plus minus 2, 0. B is -2, 0. And then here you're not going to have any because that's going to be imaginary. Because again, when you want y to be 0, and if y equals a fraction, you need the top to be 0, because 0 divided by any number is 0. So if the top equals 0, solve it, that would be your x-intercept. But in this case, you have imaginary. So it's not real. So we report no x-intercepts. We won't cross the x-axis. That was the more recent stuff. Okay, about the home stretch here. This is just old. This is like old stuff. What if you're crossing these x-intercepts? X -2, x +3. If it's 1/2, you can write as x -1/2 or 2x -1. And I'll put a y equals a times that term. Then I plug in 0 for x and 2 for y. Solve for a. So 2 equals 6a. A is 1/3. We get that. Standard form, that's kind of crazy. I don't think I'll ask you to do that. 5 for 10. That's I-81. And remember, you have to divide that by 4 and see what the remainder is. Sorry, I kind of messed that one up there, but the remainder is 1. So it's just like I, and that's what it simplifies to. If it was I-82, it'd be I squared, which is -1. If it was I-83, it'd be I cubed, which is like -I. If it's I-84, multiple of 4, you'd have just +1. It's like I to the 4 power. That's I squared -1 times -1 is +1. So hopefully that was kind of a good review of stuff. Some stuff you'll see in the final as well. Now, if I go to Delta Math, so combine complex numbers. We just said that. Do that. Combine equations from roots. We didn't quite do that in that review, but we had it in the other review and we talked about it. So, and if you show the solution, they have a funny way of doing it. I don't really agree with that. That's weird. But we've talked about like you back solve. X equals 7 plus minus 8/7. X minus 7 equals that. Square both sides. That's x squared minus 14x plus 49. Whatever that is. 64 times 7, that's 448. Move it all to one side. That's be -399. And that'd be the equation it comes from. So that's what I recommend you guys do. Polynomial division, plenty of practice there. And actually a few more. And some that are a little more challenging, some of them have remainders, perhaps. That one didn't have remainders, just has some bigger numbers, I suppose. But yeah, that one's pretty straightforward, I think. And then this one probably have remainder. Yeah, it does have remainder. It kind of shows how that works. So you have that for practice. Factor theorem. Oh, show question. So yeah, kind of we talked about earlier, like which following is a factor, not a factor. The way I'm going to do on the test, I'll tell you, hey, divide this by this, it will be a factor, and then you continue breaking down further. That's what I'll do. So that should be pretty straightforward. But you could try doing the division of x -2, for example. So I'll kind of do this one here with the guys. X cubed, x squared, -2x squared, -9x squared, -9x, 18x, 8x, 8. Okay, so that is a factor. Okay, fine. You want to go, it's not a factor. But this can be factored further, right? X minus 1 and x minus 8. Okay, so those are out. So C is the one that's not factored. Now, what if when I went through x minus 2, what if that the last number was not negative 16? So I had a remainder. Then there you go. There's the answer. And, you know, it's not a factor because you got a remainder. Like, what if I had like, negative 14? That would need to make another column, make that negative 2. I got a remainder. That's not a factor. So either way, it's not that hard. These are good practice problems with the factor theorem. Complex fraction. This is not the worksheet I just did, but you will need to practice this skill. So if you think about it, you have two fractions, 25 over x and x squared over 25. The least common denominator between those two fractions is 5x. So you're going to multiply everything up top with 5x, and everything down below with 5x. So you multiply x with 5x, which is 5x squared. You multiply 25 over x with 5x, which x's will cancel. And then you'll do x squared over 5 times 5x, and x with 5x. So it's 5x squared minus 125 all over x cubed. I think you could leave it like that, but we probably should factor things out. And actually, it could actually keep going here. That's what you should get. Yeah. Definitely gonna ask this. This wasn't on the other worksheet we just did, but remember the vertical asymptote, the VA is x equals -2. That's what makes the bottom 0. The HA, remember, if you look at this here, this fraction, the top is -2, the bottom is x plus 2. So if you focus on the leading terms, -2 over x, as x gets larger, that's what horizontal asymptote is, far left, far right. When x gets large or very negative, this just gets closer to 0. So the -3 counts as the horizontal asymptote. The x-intercept, a little tricky. 0 equals -2 over x plus 2 minus 3. Add 3 to both sides. Cross multiply. Solve for x. The x-intercept -8/3 common 0. Y-intercept's easy to plug in 0 for x. You should have -2 over 2 minus 3, so 0 common -4. So let's go ahead and do this. Horizontal asymptote. But definitely practice, guys. It's huge. But I'm doing this 2 nights before the test, so you guys have some chance to do it. -8/3 common 0, probably roughly. Y-intercept is 0 common -4. Plot it, check it, yes, and got it. And it does walk you through it as well if you need help walking through it. But that would definitely do this for sure. Discriminant. Talk about this, what it is, just practice that. And behavior for polynomial functions. So the notation. Remember, you gotta focus on the leading term. If it's even and a positive coefficient, then we expect it to be up. So it means that was x. As we go in the far right, we're up. We're in the far left, we're up. We're always up. Think of it this way. It's kind of like far left, you're liberal. Far right, you're conservative. And they're positive, both happy. So they're both gonna, rise. Fine. But if it's negative, they're both really upset, so they're both down. Odd usually liberals and Democrats, or sorry, liberals and conservatives are at odds with each other. So if like 5x cubed, then the far right's going to be positive. The far left is going to be negative. Um, I don't know. I can't really think of a good political explanation for that one. But if you have a negative, if you have a negative coefficient in odd, then it's the other way around. So if left is up, right's down. And when the left is up, if you push negative infinity, then you want positive infinity if the left is up. And if that's up, if x is going to the right, and you're supposed to be up as well, you want that as well. You want up, so that's what we want infinity. Yeah. So. Equation of asymptotes, that's good. Actually, we're not doing exponential functions, but it's a good review of old stuff, I suppose. That's a little better. So you may want to skip to that. That for sure you want to know. Remember, you said the bottom equal to 0. And they just give you the answers there, but you said the bottom equal to 0. That's exponential. That's vertical. It's exponential. Yeah, so remember, that's when x gets large. If x gets large, this fraction just gets closer to 0. Doing 24 over a large number, so it's just -6 for that one. Yeah, again, when x gets large, this fraction gets closer to 0, so it's just y equals 1. Complex roots, that's just quad form, and stating an a plus bi form. We kind of show the process here in reducing it. The difference of cubes, we talked about that already, how to factor that. And they show you like just comparing it to the formula. They might do a plot, yeah, plus as well. Now, don't worry about synthetic division, unless you're Nathan Fox. You could use box division, but if you know about synthetic division, I don't care if you use it. But you're told x plus 1's a factor, so you got to do a division, break it down further. We're going to talk about how to do that. And they should have this other technique. Don't worry about that. Just use the box division. Or -5 to 0. Do that. And this is something that's a little more advanced. I think because maybe the other zeros are radicals, maybe. Or just weird. I don't know. So I feel this is a pretty complete way to practice. So I went through that new worksheet, went through Delta Math. You have the other worksheet also. You have your notes, you have your homework, you have video lessons. You have each other, you have resources. So that's what to expect on the test. And of course the outline. Let me show you the outline one more time. Not gonna click on the test, so be careful there. Yeah. Given a root, write the equation. We talked about that. Operations, how to do that. Divine polynomials, talk about that. Given a graph or one factor, how to get the other factor, talk about that. Factoring, we talked about that, especially for sums and cubes. And behavior, we talked about that. Complex fraction, we talked about that. Sketching a polynomial. Find x, y intercepts from a rational function. Graphing a simple rational function, we talked about that. Like y equals 1 over x minus 2 plus 1. Discriminants, complex roots, find factors of roots. Talk about that as well. So you have it all. So anyway, that's kind of all I wanted to say for tonight. Questions at all? No. If you do come by during office hours tomorrow, more than happy to help you out, answer any questions we have. Okay. We'll go and end our call for tonight then. I'll stop the recording.